Welcome to part 2 of differential equations. So now we are going to be looking at differential equations that originate with more than one variable. And there's really a 3-step process that needs to be done. So if we're using prime notation instead of, dy dx notation, always make sure that you're converting your y prime into dy dx. That way, we can get the y's on one side and the x's on one side. So let's take a look at example 3. So it says, for step 1, change y prime to dy dx. So if we're doing that, we're not really, changing the problem at all, but just changing about how we're presenting the problem. And while we're at it, I'm going to call square root of x to the 1/2, because we like, when we're doing antiderivatives, we like our fractional exponents better than our radicals. That makes it, easier for us to do. Then I have 2y in the denominator. So then it says move terms with y to one side and x to the other. Now there's this handy thing from like days of geometry here. Since we have fraction on one side and fraction on the other side, what if we just did like a simple cross multiplication? So maybe I do 2y dy. I do x to the half dx. And when I got that, I have the y's all on one side and the x's on the other side. So now we have, that more well-behaved type of situation like what we saw in the earlier examples. So when we want to get rid of the dy's and the dx's, this tells us that these are the derivatives, but we want what the original function is. So we're going to, in this case, we're going to integrate both sides. So believe it or not, if you're showing me that you need to integrate on both sides, that's a large part of the concept of understanding what a differential equation is. And now we're just going to, we're just going to, at this point, take the antiderivative now. That'll be a y squared. And on this side, I get a x to the 3/2. And my coefficient was originally 1, so this is where, we may want to think about what that reciprocal of 3/2 is. And we get that plus c. So that's pretty nice. And now what we're going to do is we're going to, we have y squared. So it's just asking for, what is y? So we have to solve for y. So if we want y, instead of y squared, we could just square root. Now, if you left your answer like this, you pretty much, got the gist of differential equations, but you would not get full credit because something is missing in your solution. And that is the convention of what happens when you square root something. So to fix that problem, always remember to put a plus or minus, and that will have your differential equation completely solved. Number 4, this is a type of situation where we got like x's and y.